is super low on juice, so I'm plugged in over here. But we're going to work through this stuff. So first thing I'm going to do is I'm going to find the inverse for this function. I'm just going to write it up here so that we can see it. So we have our f of x equals 2x plus 6. What is my first step when finding the inverse of this? Switch the x to be a y. Or switch the x and the y. So first thing I need to have a y. So I'm going to switch it to my algebraic notation first. And then I'm going to grab my x, I'm going to grab my y, and they're going to change places to get x equals 2y plus 6. This is the step that makes the inverse. Now it's fixing our grammar. What are we going to do next? Subtract that 6 from both sides. So that we get x minus 6 equals 2y. Then what? Divide by 2 to everybody. So we're going to have our y equals, and you can either write it as x minus 6 over 2. Or when we put it in our inverse function notation, f minus 1 of x, you can split it into two fractions and do like 1/2 x minus 6 over 2, which is 3. Genuinely, this and this mean the same thing. I do not care how you write it. This one is easier if we were to graph it. So if we say, you know, find the inverse and graph, this would be the one you want because this guy is way easier to graph than this guy. But if we're just finding the inverse, I'm 100% okay with you leaving it like this. That's totally fine. Same vibe for the second one. We're switching it into our algebraic notation, y equals x squared. Switch our x and y to get our inverse, and we get x equals y squared. So what is our inverse function? What do we do next? Square root both sides. So square root of x equals y is our inverse function. So f inverse of x is the square root of x. And this is our inverse on this one. Questions on the bell work? Okie dokie. All right, so on the homework, we had a question like this where we're asked to find the function and its inverse and graph both. So I want us to do one like that since there's one like it on the homework. So those of you that haven't had me before, I keep a giant stack of like loose graphs for you to use if ever you need. So there's several that are like floating around on the tables, but I also put a few more out. I'm going carefully. This big graph. There's also some on the tables. So they might look slightly different. Some of them count by different scales. 10 by 10 now. And there's glue sticks in the boxes out. If you have any extra graphs, you can just leave them on the table. I'll do a whole other time in 6th period. But this gives you a graph to use so that you don't have to just like sketch it into your notebook. And I keep a literal bucket of these individual graphs. So if you ever need a graph, I got your back. Whenever we have something where we'll be graphing, I will hand you guys graphs to glue in your notebooks. Like, I got you. So what we're going to do is we are going to graph this function and its inverse. So what that means is I need to have the inverse to be able to graph it. So that means I need to find my inverse for this equation. So just like we did in the bell work, I'm going to find the equation for my inverse first, and then we'll graph both at the same time. So to find our inverse, I need to first put this into my algebraic notation, and let's use a pen, not a highlighter. There we go. So we're going to have our y equals 1/2 x minus 1. I'm just switching my f of x to be a y. Then we're going to do our step that makes the inverse, which is to take my x and my y and have them change places. So that we get x equals 1/2 y minus 1. What are we going to do here? What's our next step going to be? Get the y by itself. More specific. Add 1. So we're going to have x plus 1 equals 1/2 y. What do we do next? Multiply by 2. Multiply by what's in your denominator to get rid of that fraction. My 1/2 and my 2 are going to cancel out, leaving me with y. And on the left-hand side, we're going to multiply everybody by 2. So we get 2x plus 2. So our inverse of f of x is 2x plus 2. Questions on that part? That part's very much like what we did in the bell work and what we did yesterday. So there's nothing really new there. The only thing, air quotes, new that we're doing right now is this graphing piece. And these are both in slope-intercept form. So these are both, whoa, yes dear. Oh, I'll get you a new glue stick in a second. Y equals mx plus b. These are both in slope-intercept form. So this is pulling up an old skill. We used it a bunch last semester. We're going to use it more this semester. So we'd love to toss in a new and old review. Oh, snap. Grabbing a couple in case we forget, because these glue sticks are questionable origin. Not questionable, questionable date. Meaning I stole them from a cabinet in the math office and I don't know how old they are. But they were my favorite price. Free! All right, so what we're going to do is we're going to graph both of these lines. So we're going to graph this one first. I'm going to graph my regular function. Where are we going to start? Where is my first point going to go on f of x?
X1, 2x.
Not on 2x. We're doing this one first.
-1.
-1 on the y. So we start with a point at -1 on the y. On my f of x, how do I move to the next point?
Go up 1.
Up 1.
So right 2.
Right 2. So we're going to go up 1, right 2. Up 1, right 2. Up 1, right 2. The more points you draw, the easier it is to connect them up. It'll let me, nope. Let's see. You're going to use a ruler or a straight edge or a surface of some way, shape, or form to give yourself a straight line. It won't let me use a straight line on the iPad screen, so I draw beautiful lines. Use some sort of straight edge. Ruler if you're behind surfing cap, if you want one, but we're not going to do tons of graphing today. This is literally the only one. Then let's look at our inverse. Let's graph our inverse. Where are we going to start for our inverse? +2 on our y-axis. It's always our y-intercept. chunker dot so it's easy to see. Right at the 2. How do I find my next point? Up 2. To the right how many?
Oh, 1.
To the right 1. Up 2, right 1. Up 2, right 1. And again, you're going to use a ruler or some sort of straight edge, like so, les people. And these two lines are super closely related. If you'll notice, we have right at 2, 0 and 0, 2. 4, 1, 1, 4. Our x's and y's have all been swapped. That is the point of it being an inverse. Every time, if you graph a function and it's inverse, and you were to fold it in half diagonally, they will line up. We're not going to do much with that, but that's a thing. They will always line up on the diagonal. But that's all we're going to do is we're going to say, oh, look, they're kind of cool. They kind of match. Ta-da. But there's one like it on the homework, so I wanted us to see it. The process of finding the inverse is exactly the same. Graphing, we just haven't done in a couple of months. So we just got to remember how to graph a line. Okay? Because what we're going to do today is we're going to talk about why the heck we did composition and playing with functions before we did inverses. They feel very, very separate. I wonder what we're going to do with that. Oh, snap. We're going to talk about how to verify if two functions are inverses. Literally, the instruction will be verify, are these inverses? Or check, are these inverses? And we will give you two equations. We'll usually give you an f of x and we'll give you a g of x. And what we're asking you to do is we're going to ask you to compose the two functions together. We're going to use our composition of functions. We're going to say, does f of g of x, and then you'll also do g of f of x. So that's what I mean when I say composition. We're going to be putting it inside. And the way we can tell if they are inverses is if f of g of x equals x and g of f of x equals x, when they're all simplified down, then they are inverses. If it is anything else, 2x, x squared, opposite of x, x plus 3, anything else, all we can say is they're not inverses. So it has to equal x, just the x, and only the x. Okay, so the giant paragraph up here, I don't care if you have the whole set of words written down. We're just getting the gist. So a couple people writing, so I'm going to let you guys go for a second more. Because that's what we're going to do today, is we are going to be testing using composition of functions to see if two equations are inverses. So we're going to remember how to do composition of functions and what it means for them to be inverses. Okay? And this is the last bit of notes before the quiz, by the way. Just saying. Okay, I'm going to change the page. In 5, 4, 3, 2, 1. Change. So this will be the kind of question that you get. We'll say, are they inverses? Here's two functions. And what we're going to do is we're going to do our composition. So what I'm going to start with is doing my f of g of x. And we're going to do our g of f of x. We're going to do both. So this is where I take one of my functions and I'm going to substitute it into the other one. So our f function says 2 times a thing, but we're substituting in our g of x, which is that 1/2 x. We're substituting it in place of. Once we substitute it in, we're going to come through and simplify. What is 2 times 1/2 x? It's just 1. Just 1 x. And that's as far as we can go simplified. We're going to do the same thing on the right side. We're going to take our 1/2 times something, and we're substituting in our 2x. What is 1/2 of 2x? 1x. So if f of g of x is the same thing or equals 1x and g of f of x equals 1x, then yes, they are inverses. Because they both equal x, they are inverses. 1x is the same thing as x. So as long as it equals 1x, we're good. Let's try that again. New function rules. F of x is 6x minus 2, and g of x is 1/6 x plus 3. So they're a little bit more complicated. But we're going to do the same process. We're going to do f of g of x and g of f of x. So we're going to come and substitute this in. We're going to have 6 times our 1/6 x plus 3 minus 2. What do we need to do to simplify this? Distribute. 6 times 1/6 x, 1x. 6 times 3, 18. And then we still have this minus 2. So our f of g of x equals x plus 16. Then let's do our g of f of x. Same vibe. 1/6 times 6x minus 2 plus 3. And again, we're going to simplify this as much as we can. 1/6 times 6x, which is 1x. 1/6 times minus 2. I'm going to put minus 2/6 for right now. Plus 3. Is that going to simplify down to be just x? No. So do either of these equal x? No. X plus 16 is not the same thing as x. And x minus 2/6 plus 3, that is not the same thing as x. That is not going to equal down to just x. So are these inverses? No. Neither composition equals x. And in order for them to be inverses, they both have to equal x. So it only takes one to prove that it's not an inverse. It takes both to prove that they are inverses. It's kind of like concept. It only takes one to say no. Both have to say yes, but it only takes one to say no. No means no. Okay? So we're going to try a couple more of these, just because they're a little awkward to get used to. It's all things we've done, but they're just a little awkward. Yeah, I'm going to pass. All right. Here's 2 new function rules. Okay, good. Yeah, give me a second. Let me write this out and then I'll write your pass. So we're going to do our f of g of x. Or you can do g of f of x. It genuinely does not matter which direction you start in. Here you go, Mohammed. So we're going to come in and we're going to substitute. My 9x plus 12 over 9 plus 4/3. Whenever we're given one of these giganto fractions like this, I want us to uncommon that denominator. We're going to split it up. So this is going to become 9x over 9 plus 12 over 9 plus 4/3. And we're going to simplify this. What is 9x over 9 going to simplify down to? X. How about 12 over 9? Four-thirds. And then we have another plus 4/3. When we combine those together, what does that equal? What is 4/3 plus 4/3? Close. Does our denominator change when we're adding?
It would just be 8/3.
8/3, 8/3. Either way, does this equal x? Is my composition, is f of g of x equaling to x? Is there any chance that these are inverses? No. These are not inverses because f of g of x does not equal x. And that would be fully justified. It only takes one to say no. So if you've already shown that they're not inverses, you can stop. You don't have to do both. To say yes, they're inverses, you have to do both. So you don't always have to do both compositions. It's good practice. If you want to practice your composition skills, more power to you. But if we get one that says no, we can stop. It only takes one to say no. So let's do one more of these. We've had some fractiony ones. We've had some kind of messy ones. But these have all been linear. I wonder what we're going to see next. All right, this is our last one. Oh, hang on a second. There's a modification on this. This should, square root is just over the x. So we've got the square root of x plus 13. And the quantity x minus 13 squared. And we're going to keep going with this just exactly the way we've been doing. We're going to take our compositions and go from there. F of g of x. So we're going to come in here and we're doing the square root of our g of x. Plus 13. So we're substituting our pieces in together. What happens when we come in to simplify? Perfection. The square root and the square cancel out. We're left with just our x minus 13 plus 13. And then the 13s cancel, and we're left with just an x. So we've got a chance here. F of g of x equals x. Now we have to go the other direction. To show that it's true, we have to do both. It only takes one to say no, but it takes both to say yes. So we're going to go the other direction and do our g of f of x. So we're going to put our square root of x plus 13 minus 13 squared. And when we're simplifying, what are we going to do first? not going to square it first. I was say, think about our order of operations. We got to simplify what's in the parentheses, these 13s. Simplify what's inside the parentheses first. So plus 13 minus 13, those go away. I've got the square root of x squared. And the square and the square root cancel out. They undo each other because they're inverse operations. But these two functions, are they inverses or are they not inverses?
Inverse.
They are inverses. Be- both f of g of x and g of f of x equal x. They have to equal x, the x, and only the x, and holy cow, is my handwriting trash right there. Sorry. So it takes 2 to say yes. It only takes 1 to say no. 2 need to say yes. It only takes 1 of them to say no. And you guys have 8 minutes, 9 minutes, where you can work on homework 6-2. Tomorrow we're going to be reviewing for the quiz. There is a review up on Alex already. So if you want to start working on that tonight or when you finish the 6-2 homework, you absolutely can. It is up on Alex. It will keep generating questions. You can go over and over and over until we feel comfortable. I will also tomorrow have a paper review that you can do if you choose to. You do not have to do both. Just pick one so I can give you easy peasy points. Yeah, you can take it on Monday. And so then you can just like come in during, do you have a study hall?
No.
Okay, so you can come in during 5th period during that study time and do that. And if it takes us a couple of days, it takes us a couple of days.
Oh.